Okay, so in this video we're talking about valid conclusion in the data analysis controlled assessment tasks. So first of all, before we can talk about valid conclusion, we need to know what a conclusion itself is, and we'll deal with this in more detail when we get to the video about the marking strands. So a conclusion is a judgment about the results of your experiment and how much they support the hypothesis you've been given. So for data analysis you get given your own hypothesis, you don't have to make it up. And so you just have to look at your results and see how much they agree with the hypothesis. So things that will be in a good conclusion will be a description of the trend shown in your results, a statement about how much you trust the results based on several things, for example, how accurate they appear to be, how repeatable they might be, how well you were able to keep control variables constant, and how good your experimental technique was. Now, the first three are all mentioned in their own separate videos in this playlist, so you can go and look at what accurate, repeatable, and control variables mean to help you do that. You need to compare your trend with the one stated in the hypothesis. Does your trend support or go against the hypothesis? So it's absolutely fine if your data doesn't agree with the hypothesis to say that. And finally, the thing that people find very hard to do is, does your trend mean you have to change the hypothesis? So can you make a more detailed hypothesis, for example, from your trend? That's quite often the case, and you have to be looking out for that. Again, more detail on that in the marking strand video that deals with making a conclusion. So a valid conclusion then is one that has sort of several key elements to it. It has to make sense based on the data from your experiment, so your conclusion has to actually draw on the data that you've used correctly. Right? In other words, if you've got a correct description of the trend, you're probably okay. The experiment itself had to be done using good technique and, really importantly, all control variables kept as constant as possible. Okay, so if you can answer these three questions: have you kept control variables constant? Have you correctly stated the trend in your results and noted any limitations to it? Because sometimes you can't be 100% sure about your trend. Again, more detail when we talk about it in the marking strand video. And have you used the best techniques possible with the equipment? If you can answer yes to all of those questions, then you've got a valid conclusion. I mean, you've got a little bit of leeway on the techniques part here. You've got to have done a reasonably good job. The more strongly you can answer yes to all of these questions, the more valid your conclusion is. It's not really a valid thing. Your conclusion gets more valid as you've managed to do these three things better. So an example would be looking at this data here. This is our solar-powered car experiment again. So in this experiment, a small solar-powered car with a battery was held under a lamp for different amounts of time, and then the distance it was able to travel was measured. So I've got some sample results here and a curve of best fit plotted on the graph. And imagine you're given the hypothesis: the charging time will affect the distance the car can travel. So we have to ask ourselves, well, do our results show that? Well, they do, clearly, because the distance it can travel changes as the charging time changes. You can see from the fact, for example, that none of the range bars overlap, that there's a real difference between each of these measurements. So there's a real difference between charging for 10, 20, 30 and 40 seconds. And there's a clear trend as well, that as you might expect, if you charge for longer, then the distance your car travels is going to be further. So what conclusions can you draw from the results? Well, charging time increases, distance travelled increases. And if you want detail, you'd say it increases gradually at first, and then it's sort of steadier. It's a steadier rate of increase. So that doubling as you get up to past sort of about 20 seconds, if I double the charging time, I've kind of doubled the distance travelled. There's a good degree of repeatability shown by the small range bars, and remember, high repeatability suggests that you've done a good job controlling the control variables, except for this 30-second data point. You have to acknowledge if there is something that's wrong with your data. Don't try and hide it. You're not going to gain marks by pretending that your data is better than it really is. You've got to be honest about it and note the things that are wrong with it. Experiment appears to be accurate as all the points are close to the line of best fit. Again, all of these things are dealt with in more detail in their respective videos, repeatability and accuracy. And so you've got a fair degree of confidence, given those three things, that the trend is correct and the data is valid. And so your conclusion will be valid as well. That it does, yes, it agrees with the hypothesis. We won't discuss it here in much detail, but again, you can do a better job than the hypothesis. You could change that hypothesis to be much more detailed, right? Rather than saying the charging time will affect the distance the car can travel, you could improve on that hypothesis with your data, saying as the charging time increases, the distance travelled will increase. So you then have what type of relationship exists between the two quantities, not just that one will affect the other. So that's an example of an improvement you could make to that hypothesis, and there are others. So it's important to note that a full conclusion will have more discussion than this. We're only really those 4 bullet points are only really what we talk about to describe whether the conclusion is valid or not. Okay, there we go.